All right, so this video is all about simplifying exponents. So we are in Unit 1, which is our Revisiting Quadratics unit. Um, and so I'm going to start off by showing you some different properties. And these properties are actually properties you should be familiar with from um, previous classes, okay? But in Algebra 2, our standard is to extend the properties of exponents to include rational numbers. And so a rational number is a number that can be rewritten as a fraction. So you'll notice that like we have x cubed times x squared, those are whole numbers, right? But 2/3 and 1/5, those are fractions. So those are considered rational exponents. So I'm going to kind of use the whole numbers to help kind of refresh your memory, and then we'll extend that to include rational numbers. So one thing that you need to notice is that here you have a to the m power times a to the n power. Now notice that the a's are the same. Now that could be a variable or it could be a number, all right? So, but the key is that base should be the same, all right? It has to be the same in order to use these properties. So instead of multiplying though, like you think you should do, properties of exponents have their own set of properties. So you don't treat it the same as you do normal numbers. It's not like in elementary school when you said, oh, 5 times 3 is 15. This is not the same thing. We're not dealing with just regular numbers anymore. We're dealing with exponents. All right, so the property of exponents is when you're adding, or I'm sorry, when you're multiplying and you have the same base, instead of multiplying, you add. All right, and of course you keep the base. All right, so when you multiply, you add. So when we look here, we have the same base, x and x, right? So that means that I can add my exponents. And 3 plus 2 is 5. All right, now for the next one, it's the same thing. We have the same base. They're both x's. All right, so that means we can add our exponents. And I'm going to use my calculator to kind of speed things along, but if you have to do it by hand, then obviously you'd have to get a common denominator and all that kind of stuff. But we can add 2/3, if I could do it correctly. Let's try it again. 2/3 plus the 1/5. All right, and I get 13/15. So this would be x to the 13/15. All right. The next one that we have is a power of a power. So if you have a base raised to an exponent and then you have it raised to another exponent, that's considered a power to a power, all right, or power of a power. So when you have a power of a power, you multiply, all right? So power to a power multiplies. So in this example, we have x cubed to the second power. So 3 times 2 is 6. So you multiply the exponents. And then the one with the rational exponents, we are still multiplying because it's a power to a power. So we have 3/4 times 2/3, which is 1/2. So this would be x to the 1/2 power. And you're going to learn later that x to the 1/2 power is the same thing as the square root of x. All right, but I'm not going to get into that too much right now. All right. All right, so the third property is power of a product. So that means that you have 2 things in parentheses, or 3 things, or 4 things, but basically all of these are being multiplied. So like the A and the B are being multiplied. Well, when you have more than one thing being multiplied and all of it, the whole thing is raised to a power, then everything in parentheses gets raised to that power. It's almost like distribution, except distribution is multiplication, right? But in a way, we're distributing this m to both of those variables. All right, so A gets raised to the m power, B gets raised to the m power. So in our example, we have a 3, and we're going to have 3 to the 4th power, and we have x to the 4th power. So we need to figure out, well, what is 3 to the 4th power? All right, now I know it's 81, but if you didn't know, then you'd say, okay, 3 raised to the 4th power is 81. So I'd have 81x to the 4th power for my answer. All right. The reason why I did take the time to put it in parentheses is because sometimes you're dealing with negative numbers, and sometimes negative numbers you need to have in parentheses because when you raise them to a power, your calculator uses order of operations, and you may see some mistakes if you don't. So I like to kind of get in the habit of using parentheses. All right, so another property is the negative exponent property. All right, we have a negative exponent right here. All right, now if you have a negative exponent, it's kind of like improper math. Okay, so in your English class, you have to, when you write a sentence, you start it off with a capital letter, you end it with punctuation, right? So there's a proper way to do it. I could say, my name is Christina, and forget to capitalize, my name, like M, and forget to capitalize Christina, forget to put a period at the end, and you still know what I'm talking about, but it's not proper. All right, so in math, it's not proper to have this negative exponent. All right, so instead, I like to say you turn that frown upside down. All right, now if the negative exponent is a part of the numerator, you flip it and it goes to the denominator. And if it's in the denominator, you flip it and it comes up to the numerator. And when you do flip it, when you turn that frown upside down, the negative goes away. All right, so I know it's kind of cheesy, but it's like if you're not happy, then move. Go somewhere where you're going to be happy. All right, so you flip and you turn that frown upside down and make it happy. So that's what you're going to kind of hear me refer to. All right, I'm going to say, is it happy? Is it not happy? That kind of thing. All right, so in this example right here, you have 3 to the negative 2 power. Well, it's not happy, so we're going to flip it. But remember that this is technically over 1, right? So when we flip it, we have 1 over 3 to the positive 2 power. All right, so I turned it, flipped it, and it became positive. And then 3 squared is 9, so 1 over 9. All right. For the second example, it looks like it's crazy hard, but it's really not. It's all about looking at the exponents because every single one of these bases are different. All right, and since all of our bases are different, we're not going to be using, the product property, or the product of powers property, the power of a product, power of a power. Like we're not going to be using any of these other properties. Okay, so we just need to pay attention to our exponents. So I'm just going to kind of go through and think about, is it happy or not happy? So for this first one, y squared, it's happy, right? So I'm going to keep it in the numerator. Well, x to the negative 3 is not happy, so I'm going to move it to the denominator and make it happy. Z to the 5 is happy, so I'm going to keep it up there. A to the negative 5 is in the denominator. It's not happy, so I'm going to flip it up and put it up here. So a to the positive 5. B squared is happy. And then c to the negative 3 has to move up and become c cubed. All right. So I've made all of my exponents happy, all right, or positive by flipping them. Okay. So that's kind of how I remember that. Turn that frown upside down. We don't like negative exponents. We want everything to be positive if possible. All right. Now the next property is called the zero exponent property. And it says that anything raised to the 0 power is 1. All right. Anything to the 0 power is 1. So 4 to the 0 power, 1. Elephant to the 0 power, 1. All right. Negative 8 to the 0 power, 1. All right, so anything to the 0 power is 1. And what do you think the most common mistake is? Somebody sees that 0 power. What do you think they're going to think? They're going to think it's 0, but it's not 0. All right. All right, so the last couple of properties deal with quotients. All right, so you have quotient of a powers. So this is when you're dividing with exponents, but notice again that the base is the same. All right, so in order to use this property, the base has to be the same. But when you divide, you really subtract your exponents. All right, so there's a couple ways I think about this. Number one, I kind of think about this little fraction bar almost like a subtraction symbol. You know what I mean? It's like m minus n. Okay, it kind of goes in order. All right, so m minus n. So if you are dividing, you subtract your exponents. All right, so in this first example, 7 minus 4 would be x to the third power. Now, for this next one, 2/3 minus 1/3 is just 1/3. So you would have x to the 1/3 power. All right, so again, subtract your exponents. All right, another way I remember that is when you multiply, you add, when you divide, you subtract. So with multiplication, the multiplication symbol looks like a tilted plus sign, right? So when you multiply, you add, and when you divide, think about taking these little dots away and it looks like a subtraction symbol, or the fraction bar looks like a subtraction symbol, right? All right, so when you multiply, you add, when you divide, you subtract. Power to a power, you multiply. Negative exponents, nope, turn that frown upside down, okay? Anything to the 0 power is 1. All right, and then if you have more than one thing in parentheses, remember it's almost like distribution. You have to distribute your exponent. So this m gets distributed to the a and the b. So I have a to the m power over b to the m power. So it's not distribution like multiplication. It's more like you're tacking that on to each of those base numbers, all right, or each of those numbers. It can be a number, it can be a variable. So, all right, so we're distributing that. So if we look at this first example, we would have 5 squared over 3 squared. And if you can do the math, go ahead and do it. So 5 squared is 25, 3 squared is 9. And if you could simplify, you'd simplify, but this one cannot simplify. All right, so then this next example is a little bit tougher, all right, because number one, it's got a couple of things happening. All right, so it has a negative exponent, but it also has more than one thing in parentheses raised to that exponent. So I know that I need to distribute my exponent, but I also have a negative exponent, which tells me that I can turn that frown upside down. So there's two different ways I could do this problem. One of them is I can deal with that negative exponent. I could say, okay, well, if I have a negative exponent, I'm going to turn that frown upside down. I'm going to flip everything, right? And when I flip everything, I would have 3 over 2 instead to the positive 3 power. So if I did it that way, I flipped my original fraction, and when I flipped it, it gave me that positive exponent. So now I have 3 cubed over 2 cubed, which is 27 over 8. And nothing simplifies. All right, so that's one way that you could do it. All right, now the other way that I could have done it is I could have said, well, I'm going to go ahead and distribute that exponent, right? I could have said I have 2 to the negative 3 over 3 to the negative 3. And then I would have flipped, okay, and said, okay, I have 3 cubed over 2 cubed because I'm turning those frowns upside down to get the 27 over 8. So I could have really done it in either order. I could have went ahead and taken care of the negative exponent and turned that frown upside down, or I could have went ahead and distributed that exponent to each of the terms in parentheses. All right, so those are your properties of exponents. I did want to look at a few more examples just to kind of make sure. All right, so some additional examples. These are a little bit more complicated, but when you are, think about order of operations, please excuse my dear Aunt Sally. In this problem, I have multiplication and division. So I'm going to go ahead and take care of this numerator. And I do want you to also notice real quickly that all 3 of these are m's. I can only do this if they're the same base, right? In this problem, they're both w's. They have to be the same base in order for me to use some of these properties, all right? Unless I'm distributing, like if I have more than one term in parentheses and I'm kind of distributing the exponent type thing, that's the only case where you're doing that, something a little different, all right? Because it's more of a distribution. Here, we're trying to simplify these terms, all right? So when I multiply, I add, but when I divide, I subtract. So what I really have then is m to the 2/3 power minus, or I'm sorry, plus the negative 1/2 power minus the 1/6. All right, so, and I can do this because they're all the same base, they're all m. All right, so I'm going to have 2/3 plus a negative 1/2, and I could have just said minus 1/2, right? Oops, I messed up in my calculator. All right, let's try that again. All right, so 2/3 plus a negative 1/2, or I could have said minus 1/2, and then minus 1/6. And I get 0. All right, so m to the 0 power, and anything to the 0 power is 1, not 0. All right, so that one looked a little bit more complicated. Now, I could have done some stuff and said, well, there's a negative exponent. Let me turn that frown upside down. But it was actually easier for me to just go ahead and deal with everything, deal with the adding and subtracting, and then just see what happens. You know, if it happened to be negative at the end, then I could have turned that frown upside down. All right, so for this next one, again, I could sit there and flip this up and all that kind of stuff. But because I'm dividing, I'm just going to go ahead and subtract. So I have a 1/6 minus a negative 2/3, which subtracting a negative is really the same thing as addition, right? But I'm just going to go ahead and type it like I have it. So 1/6 minus a negative 2/3. And I get 5/6. So w to the 5/6. Now in the end, my exponent's positive, so I don't have to worry about turning that frown upside down. Another couple of examples. All right. So these have different terms. We have numbers, we have A's, we have B's. All right. So we have kind of a mix going on here. So when you see things like this, you want to work with each one independently, because remember, I can only use properties of exponents, you know, where I'm multiplying and dividing and things like that when the bases are the same. So when I look at this, I'm going to have my numbers, I'm going to have my A's, and then I'm going to have my B's. All right, so I'm going to kind of do them independently. So the first thing I have is 10/12. All right, well, 10/12 would reduce to 5/6. So I'm going to go ahead and set up my fraction bar, 5/6. All right, then I have my A's. All right, now this is where I'm going to teach you something a little bit different than what I did before. Okay, so I have a to the 4 over a to the 8. Now, what I should do is really say, okay, a, like 4 minus 8 is -4, right? And then I would turn that frown upside down. All right, so this is where I kind of talk about top heavy versus bottom heavy. All right, so we're still going to subtract our exponents because we are subtracting, but instead of subtracting and having a negative up top and then turning around and have to flip it, I think about, well, this is bottom heavy. So instead of saying 4 minus 8, I'm going to say 8 minus 4. And I know because it's bottom heavy that it would stay in the denominator. So I would get a to the 4th power in the denominator. And then for my B's, I'm going to subtract, but because it's top heavy, then I know I'm going to say 7 minus 5 to get B squared. All right, so this would be our final answer. So you could subtract, like I could have said, you know, I could have went, okay, 5/6. I could have said a to the -4, b squared, and then said, oh, I got to flip some stuff. So 5b squared over 6a to the 4. You know, I could have done it independently, but it was just easier for me to kind of take care of it all at one time. All right, so then this next example, we have a few things that we can do because we have some, you know, we have things in the parentheses that have common terms. All right, and then we also have this exponent up here. So I'm going to go ahead and work within my parentheses first. So I have the 2 and the 5. I have the x's, right? I have the y's. All right, and then I have the z's. Okay, so those are 4 different parts. So I'm going to kind of go ahead and set up my my fraction bar, and I'm going to have 2 over 5. That doesn't change. And we'll deal with that square in a little bit, okay? So don't forget the square. All right, so then with my x's, 5 minus 2 is 3, and it's top heavy. With my y's, it's bottom heavy, so 4 minus 3 is 1, so y to the first power would be just y. And then my z to the negative 2, it's not happy, so I'm going to move it to the denominator and make it happy. So I have a z squared. And then I also have the square power, right? The second power. So I'm not done. I've taken care of my inside of my parentheses. Now I've got to take care of this exponent. So every single term gets squared, every single one. So I have a 2 squared, right? So 2 squared is 4. X cubed, well, power to a power, right, gets multiplied. So x to the 6 over 5 squared is 25, y squared, and then z squared squared, power to a power, multiply to get 4. And then just double check that nothing simplifies and nothing does. So this would be my final answer. Whoops. All right, so the last couple of examples, all right, we have a lot of things going on in parentheses, a lot of things in parentheses again, and we have an exponent, right? All right, so what we need to take care of first is, when you use properties of exponents, please excuse my dear Aunt Sally, we have to deal with this exponent stuff first. We don't have anything inside individual parentheses that we can simplify. So we go ahead and move on to our exponent. So I'm going to keep my first parenthesis, 9a cubed b to the 5. But then my second parenthesis, I have to take every single one of those terms and square it. So this is where parentheses matter. This is a negative 4. So if in my calculator I put negative 4 squared, it tells me it's negative 16. That's because it's using order of operation. So be careful. You put negative 4 in parentheses and square it, because a negative times a negative is really a positive. So just be really careful with that. So this would be 16, and then a cubed, 3 times 2 is 6. B to the 7, 7 times 2 is 14. All right, so remember, with power to a power, you multiply. So now I have individual terms, okay, but these are in parentheses, these are in parentheses. So technically I am multiplying. And when you multiply, you add. Okay, however, be very, very careful. All right, 9 and 16 are not exponents. All right, 9 and 16 are normal numbers that we've been dealing with for like ever, right? So you do not add those. You legit multiply them. And 9 times 16, so I don't make an error, is 144. All right, so I would have 144, but now my A's are being multiplied, and those are dealing with exponents. So when you multiply, you add, and 3 plus 6 is 9. Oops. A to the 9. And then B, 5 plus 14 is 19. All right, so when you multiply, you add. All right, so last example for this lesson, we can go ahead and take care of things in our parentheses first, because we deal with parentheses and then we deal with exponents. So I'm going to go ahead and start setting that up. All right, so I'm going to have my 4 and my 6, and I don't know if the highlighting helps you, but I'll go ahead and highlight just so we can see it. But I have my 4 and my 6. I have my M's, right? I have my n's, and then the last one, my p's. All right, so I'm going to go ahead and kind of deal with those. All right, so 4/6 would reduce to 2/3. All right, so then I deal with my m's. It's top heavy, so 4 minus 2 is 2, so I would have m squared. The n's, be careful, the n's are bottom heavy, all right, because 2 is bigger than -3. So I know my n's are going to be in the denominator, but I've got to figure out the exponent. So I'm saying 2 minus a -3, right? So be careful. When you subtract a negative, it's really a positive. So it's really going to be n to the 5. All right, another way to think about that is if I turn this round upside down, it's changing signs. It's becoming a +3 in the denominator, right? So 2 and 3 make 5. So there's a couple ways for you to kind of think through that, but that one's a little bit tougher. And then the p squared is already happy, so we'll leave the p squared in the numerator. And then we have a -2. All right, so at this point, we have a negative exponent. So, or we can deal with the negative exponent, or we can distribute that negative. I'm going to go ahead. I prefer to go ahead and flip. All right, so I'm going to go ahead and flip. So this all becomes flipped. 3n to the 5 moves up. 2m squared p squared moves down, and it's to the +2 power. All right. So I literally just flipped and then made my exponent positive. So now every term is going to get raised to that exponent. So I have 3 squared, which is 9. A power to a power gets multiplied, so n to the 10 over 2 squared is 4. A power to a power gets multiplied, so m to the 4, p to the 4. And that's my final answer. Always double check nothing else simplifies, but nothing does. So we are good. All right, so that is the properties of exponents. And now you can complete your practice work.